Alright, so today we're going to finish Invertebrates as promised. Hope you all enjoying your day with Mr. Kimasek. I know he enjoys spending time with you guys, so hopefully you can talk him into reading something out of the book or telling you some sort of crazy story when we're done with this. But let's get through this so that we're ready for the test on Monday, and we can kind of carry on with all that. So, I believe this is where we left off yesterday with this data table, basically going through the major subphyla of Arthropoda. Or the arthropods. We have our cheliceraforms, which are our more primitive animals, horseshoe crabs, sea spiders, regular spiders, scorpions, ticks, mites, that sort of thing. Millipedes, centipedes are all part of Myriapoda. Hexapods, insects, springtails, that sort of thing. Normal insects that we see walking around anywhere that you go. Those are our hexapods, and then crustaceans down here. When I see crustacean, again, I see crusty ocean, so I think of these crusty little animals that live on the bottom of the ocean: crabs, lobsters, crayfish, shrimp, all that kind of stuff. So that's some of the stuff that I think of. Again, these tables are going to be great. You're going to want to study these tables for the test. That would be where I'd spend a lot of energy. So, cheliceraforms, subphylum cheliceraforms, are named for claw-like feeding appendages called chelicerae. Those are tiny little things that we see kind of near the mouths of things like your lobsters and stuff like that. So there's these tiny little feeding appendages. Earliest cheliceraforms were Eurypterids, which are water scorpions. Most marine cheliceraforms, including Eurypterids, are extinct, but some species survive today, including the horseshoe crab. The horseshoe crab has those, chelicerae. They're a very primitive-looking animal. They kind of look like these armored cars or tanks, and they just kind of carry on the bottom of the ocean. Sometimes they'll wash up on shore. They've got a pretty long, sharp tail, and they're kind of cool-looking. But cheliceraforms. And this is a pile and these ones I believe are even still living. These are the horseshoe crabs. Again, they just kind of look like a tank or an armored car. Kind of cool animals, very primitive, early looking. You can see, kind of cool. Most modern cheliceraforms are arachnids, which include spiders, scorpions, ticks, mites, that sort of thing. Obviously everybody's seen these, spiders, scorpions, ticks, and mites. Arachnid is characterized by having in the neighborhood of 8 legs, as you see with spiders. But ticks, scorpions would be in addition to those spiders in that group. So arachnids fall within cheliceraforms. And we talked the other day about dust mites and how the mites live on your hairs, will feed off of your skin, feed off of your oil, that sort of thing. We've talked about scorpions. Obviously, everybody's seen spiders, not a whole lot to them. In Chemo's book, there is a segment on the breeding behaviors of dust mites, so maybe he'd like to read that section for you today, seeing as that kind of meshes with what we're dealing with. So that would be kind of a cool thing to discuss. And a close-up, okay. This is the part you want to avoid, obviously. And this isn't so good itself. So they're kind of a mean little beast, but interesting nonetheless. This would be a microscopic view of what the dust mite looks like. Again, kind of the armored car type of idea. Lots of external structure, keeping that rigid formation of the body and so on and so forth. So that's our dust. And then finally the spider. Spiders are pretty interesting. The way that they can survive and adapt and all that kind of stuff. Spiders are actually one of the more fascinating animals. Arachnids have an abdomen and a cephalothorax, which has 6 pairs of appendages, the most anterior of which are the chelicerae. Anterior, again, being most located in the front. The frontmost are the chelicerae. They're the ones used for putting food into the mouth. Gas exchange in spiders occurs in respiratory organs called book lungs. It's kind of like, it's almost like an adapted gill type of thing. But not necessarily all the way to a lung, not all the way to a gill, kind of a middle ground between them. Many spiders produce silk, a liquid protein from specialized abdominal glands. That silk, for its diameter, is one of the strongest materials that there is naturally occurring on planet Earth. And it's kind of cool that arthropods are able to produce those. Here's kind of the body layout and the plan here. if we take a look, they do in fact have kind of a primitive brain. It's more a collection of nerves. They have several eyes, as we see. Poison glands, some of them are in fact poisonous. The most poisonous spider that there is the daddy longlegs, although the fang on the daddy longleg is not long enough to puncture through the skin of humans. It's very, very toxic for things like insects that it catches. It is the most toxic spider, which is kind of interesting. Here's the book lung, which you can kind of see is very similar to what you would see in a gill type structure, but it's also kind of a chamber where it might be similar to a lung. So kind of the middle ground there. The gonopore, which is the exit for the eggs. Eggs will come out of there. Sperm receptacle right up there, so that as it's laying the eggs, it can mix it with the sperm and fertilize them. So they do have kind of an internal fertilization. They can be, obviously that sperm receptacle is going to be filled with sperm by a male, and they can fertilize as they expel the eggs, mix them with the sperm. So kind of an interesting beast. They have a primitive heart type of structure. It's more or less just muscles surrounding an enlarged blood vessel, but that's what we're dealing with here. I guess that's about it. Okay. Myriapoda includes millipedes and centipedes. Myriad, it means just like a ton, a mess. Poda means legs, so just a mess of legs, I guess, is what you could translate it to. Are terrestrial, have jaw-like mandibles, so they actually have a mouth structure rather than just opening and closing and putting food into an opening in their face. Millipedes are diplopoda, which means they have many legs, but the dip part comes from the fact that it has 2 pairs of legs for each trunk segment. So each little segment on the millipede has 2 pairs of legs on it. And here's what we're dealing with here. When you see them move, obviously you can see one segment is like right here, and they'd have 2 pairs of legs on that one segment. When they move, their legs, you can kind of see this as individual waves, and those waves will just basically move all the way along the length of its body, which is kind of cool to watch them move. And they can get pretty long. In South America and other places, you get these big, gigantic centipede-looking things. They're pretty cool. Centipede class, Chilopoda. They are carnivores. They have 1 pair of legs per trunk segment. So again, we have about half as many legs per unit, I guess, or per segment. For centipedes as we do millipedes. They don't have 1,000,000 legs, and they don't have 100 legs. I guess they could have 100 legs, but they have to be pretty long. So that's essentially the key differences between the millipedes and the centipedes. Millipedes have the 2 pairs of legs per segment. Centipedes have the 1 pair of legs per segment. And here's what a centipede looks like. Carnivorous beasts. They'll eat, depending how big they are, they'll eat bugs. If they can get a hold of a slow or dead or, I don't know, maybe a fetal rodent or whatever it may be, something that's relatively vulnerable, they can eat those things. So they are kind of an aggressive beast, I guess. They're very quick, kind of fun to watch.